Hello, everyone, and welcome to the video talk-through for the book From Social Science to Data Science by me, Bernie Hogan. This is Chapter 2, the series. So today we have a number of learning goals that are really just related to the series, which is a really important tool, really useful tool in Python, and is a real basis for a lot of other data analytic work. It's kind of your main tool, like your main knife if you're a chef or something like this, or a hammer. But the series is something you really want to get used to and get comfortable with. So the first thing we're going to want to do is understand the series as a data structure, and one that allows index and position. So we can ask for things by label, or we can ask for things by the order within where they are in the series. We're going to want to be able to change the index and the values of a series. So not just have an index that's like 1, 2, 3, 4, but it could be the index being what day of the week it is, or some feature about a case. Maybe it's case ID, and use that as an effective way to manage the data along the way. We're going to want to perform operations on the series that do things like summarize it. So we'll have a look at value counts, and we'll look at the mean. We'll look at some others in the code, and try to understand differences between functions that we could use on the series and methods which are kind of like functions, but they're properties of the series itself. And we'll see syntactically how they're slightly different. And then we're going to want to recode some values in a series, and maybe change a value, add a value, or transform the entire series in some way. Maybe transforming it from a list of characters that were read in from a CSV into a series of numbers that we can use to make calculations on. So if we say the series is a way to contain or to manage a distribution, well, what's a distribution? Well, distribution is a collection of measurements. There might be numbers of friends, lists of one's favorite songs. There could be blood pressure readings, or a number of shooting stars seen per night. It could really just be anything. As long as we can get a distribution of it. And now distribution doesn't have to be of numbers. Within a series, we can get a whole series of an ensemble, or a collection, if you will, of texts, and then we can summarize those texts in some way to get something meaningful out of them. Just the important thing is that we get a collection of such measurements to do things with and to compare. So Python may contain distributions of a variety of objects. We can have them in lists. A list is the classic one, and so they store data by position. So let me get my mouse over here. All right. And we can see this is a list. It's got these square brackets here, and we've got 4 elements in it. And then if you add a new value, you would append that value to the end. So we could ask for it by position. In this case here, we say what's in position number 2. You notice up here that it says it's 43. You'll also notice some syntax that I'm using here. You didn't see this in the first chapter, but for the sake of the PowerPoint presentation here, instead of having the code on one line and the output on another line, generally I will use these 3 chevrons here in order to show that this is the output for this. So in this case here, we say what's the element in the second position, or the 2 position really, and I did that deliberately to point out, as we might remember from other things about Python, that we start from 0. So this is the 0th position. This one's in the first position, number 2 and number 3. If we were to append a value to that, maybe exlist.append 5, then that'll go at the end. Now that's not the only way to look at a distribution. We may think of that in terms of key value pairs, or a collection in terms of key value pairs. So here I have an example where the keys are as times of the day when one might eat some food, and then the values in this case are the food they would eat. So in the morning, cereal; lunch, salad; and dinner, pizza. So regardless of the order, it doesn't matter what order you put them in, you can still ask for what was dinner, and then we'll get back pizza. Now, as it happens, since Python around 3.5, I believe, the default dictionary is an ordered dictionary. So when you add things to this dictionary, it will remember the order that you added them in. But that's not important for a dictionary. In most cases for a dictionary, we want to get the key value mappings. The other thing is that even though it's ordered, you can't query it by position. You can't say what was the 0th element of the dictionary. but it is useful sometimes to remember that the dictionaries, the values went in some order and then can be retrieved in that order as well. But now what about a data structure that can store both by position and through key value pairs? In other languages, like JavaScript, that might be an array that can do that. And you can't do it with some other structures in Python, but particularly the series through pandas can do that and can do it well, and involves all kinds of additional ways of manipulating the collection of data that's in that series. So we look at this through pandas, which is a short name for the Panda or the Python Data Analysis Library. All right, so let's have a look at the series itself. The series is an object in the pandas library. You can import it by itself. You can say from pandas import series, but normally we wouldn't do that. We would normally import the entire pandas package, and when we do that, we often use the shortened version, as PD, as we see right here, and then you would say pd.series to instantiate a series. So you can see that here. We can instantiate an empty series like so, or we can do it with a number of different collection kinds. In this case, we can have one for lists, or we can have one for dictionaries right here. And they'll both be a series. Now, in this case, with the dictionary, as you may have guessed, the keys are going to end up being the index, and the values are going to end up being, well, just the values of the series. Whereas in the list, the index is going to be 0, 1, and 2, unless you specify something else right there. A series is always going to have an index, but it might just be 0 to n. That would be its range index. Or it might have a different index depending on how you got the data in. The series will have a name, or it could have a name, and that name can be useful because then if you merge that series into other stuff, the name might end up being a column if you merge it into a data frame, and it'll be the column name. A series can include missing values or null values, so you might have a place where you get some values for some rows, but the others are just empty. Either maybe there was no text in that tweet, so there was nothing to put in a text of the tweet column, or anything. You'll be surprised about where missing values can pop into in a lot of this work. But now they're stored in the series as NaN values, and we'll see how to toy with that in a bit. And indeed, we have the Jupyter symbol over here, and so that we can actually go over and see us doing this in Jupyter. And I'm going to flip over and do that now. Okay, here we are, and this is chapter 2, and you'll see here it's from the book and all that sort of stuff. And once again, we have all the output. So what we're going to do is I'm going to restart kernel and clear all the output. Okay, oh, look at that. Now you'll also notice this time around what I'm going to do is I'm going to look at the table of contents as well. So on the left-hand side here, you see these table of contents, and the reason is because I'm not going to go through all of the code in the presentation. I'm going to kind of move back and forth a little bit between it and use the code here when I want to accentuate something really important, or where I think the longer space afforded by JupyterLab is going to be helpful. But sometimes we can just get away with seeing what's on the slide. So first I'm going to import pandas. That didn't take very long here, and now we have a list. That list I'm going to call weekdays, and now just look what I can do to instantiate it as a series here. And I even give it a name. I call it weekdays. And then see here I display this. Now the display is, it's just monospace text. When we get to data frames, we'll see a display, and it'll make nice HTML text, but that's down the road. Now over here, instead of just the days of the week, imagine if we did this with the days of the week as keys and some value as the values. In this case, I went for like a fictional hours of sleep per night. Today being, I'm actually doing this on a Monday, so maybe I'm anticipating a slightly below average night of sleep, but who knows. Okay, so I'm going to move that up here. And what we can see here, that's the dictionary, and then we're going to make the series from the dictionary, give it a name as well. You don't have to, but I do like doing that, and display it. Now you'll also notice down here I print as well. We can use print and display within IPython. Print is more robust because it can work in any flavor of Python, and display can often pull in some special features of JupyterLab or IPython, depending on the context. Here, of course, being JupyterLab, it'll have some special features for JupyterLab. I don't use those a lot, but I do, as a matter of practice, like using display. Okay, so let's run that. Let's see here. See that the index, we got the values, the name. The D type is float. Now you notice it's float, so these things here like integers, they all get upconverted. So it's going to have the whatever takes the more precision. In this case, there's some 0.5 values, and so everything gets up converted to a float value. And that's because, well, what pandas wouldn't want to do is round up or round down and just guess. I mean, it doesn't want to guess because that would destroy information along the way. And where possible, it usually tries to avoid destroying information. Okay, so now let's see. We've just created some series there, and like so. Now we can get data from a series in a variety of ways. Most obvious, as we alluded to, would be by index and position. Now an index that starts off, it's just 0, 1, 2, 3. It actually is created using a range index object, and I'm not going to cover that too much in the talk through, but you can see that over in the book how I show how you can use the range index object to create a new range for your series. But you can access each element in a series. You can do it by label. So if, in the ones over there, we had the index being days of the week. So if it's Monday is one of them, it'll return whatever the Monday value is. Notice that Monday here has an uppercase. Indeed, Python is pretty case sensitive everywhere. So you're going to have to watch that. You can also get it by position. You can request the nth element in a series. And the series is always going to have an order, even if you can reorder it. And you can do this iteratively. And actually, notably, I don't do this in the book because I don't really do this a lot myself, frankly. But you can iterate through a series as like a for object. And in this case right here, for value in series object print value, you'll notice that how that will give you the value one after the other. For index in series object dot index, look at this. When you put dot index at the end, that's how you can get each index one after the other. And finally, if you look at a pair, in this case, series object dot items will give you a pair of index and value. So index and value, index and value, index and value that you can make use of. Like I said, I don't normally use that, but it's available if you need it. And we can kind of see how we do that over here in Firefox once again. Okay, above here we went with Tuesday and or sleep hours 2. Now why 2? Well, I just wanted to compare because it should be 0, 1, and 2. So it should give me the same thing. There we do. Look at that. It's a float, just for what it's worth. And we can see here we can check those data types. But down here, I wanted to point out something. Look what I've done. I've used the number 4 instead of Sunday. For whatever reason, I replaced Sunday with 4. So now what's going to happen when we index? Is it going to index by position or is it going to index by label? Well, as it happens, it looks for the label first, and if it finds it, it gets it, and if not, it assumes that that's a position. So in this case, it didn't give us 0, 1, 2, 3, 4, this value. No, it gave us this value right away. So you got to be careful not to use numeric indices if you want to query by position, unless the numeric indices is literally just 0, 1, 2, 3, 4, 5. Now, where's that relevant? Say, for example, later on in the book, we'll look at a stack exchange, and each stack exchange has comments and posts, and each post is given a number, an ID. And that ID can be useful as an index, but it doesn't start from 0, and it doesn't include every number. And so I chose then to keep it as a string value. And the reason I did that is so that we don't confuse it between, indexing by position and indexing the ID number, which might be 43 or whatever. Okay, so let's move on back here. Now, another way to get data from a series, and this one's a little more tricky, but I think it's really useful, and that's the way to get a subset of the series. Now, we call this a mask, and so what it means is that we can create a truth condition, and if the elements of the series meet that truth condition, well, they'll get a true, and if they don't meet it, they'll get a false. So you get you start off with a series, and you get a bunch of trues and falses out of it. And you can use these Boolean operators. You can say, does it include this or that, this and that, equal to this, and so forth. And we'll see them in practice now in a sec. So here we have a series with 4 numbers. And then if I just use this, greater than 30, it's going to say, no, that's not greater than 30. Remember, I didn't say greater or equal to. I just said greater. So it's false. Second time, false. But yeah, that's greater than 30, so it's true. And that one is not greater than 30, so that's false as well. Okay, so that's cool. We got a new series, and that new series has this truth condition in it. Now, what can we do with that? Well, that there is the mask. That's the mask that says show this, don't show this, etc., etc. So just watch what happens when we take this right here, series.object, and then we insert it inside of an index. So it's actually, we're seeing series object a lot here, aren't we? It's just the name. But just, yes, to notice that you can put that inside of an index itself. And then the true ones will appear. Now, that's a bit of a bug there. It shouldn't be 21. Maybe I had a different condition there earlier or wasn't paying attention. But that's because I typed this out and not done it, and not having done it in Jupyter. We'll do that now in a sec. Before we do it, though, I want to show how you can add multiple comparisons at the same time. So the first one here is it greater than 30? And then we say, okay, false, false, true, false, false. And we might say, or is it less than 20? So we're getting either side of the distribution. So this pipe right here, as we mentioned, that's an or. We could make an and. That would be nothing because it would be logically impossible for it to be both above 30 and below 20 using this sort of number scheme, certainly. So in this case, it's this or this, and then instead of this false, false, true, false, now we pick up an extra value, one that I guess is below 20, and so that's this one right here. So we can see like that is so. And then we can go over to Jupyter and have a look at some of these in practice. Okay, so now if you'll notice over here, I'm going to look at the table of contents and find out where we want to go for that. So I'm going to say working from values and masking. Click on that. Here we are. So this is one mask. Display sleep hours less than 7. There we go, and you can see Tuesday and Wednesday sleep hours less than 7. 5 hours, 6.5. Not really very good. So now, as a horrible pun, I'm going to call that a sleep mask, and then what we can do, we can put the sleep mask inside here. Now, I mean, I could have just as easily, I suppose, put sleep hours minus 7 in there, but I wanted to show that you can make that Boolean as a value, and then when you do that, so then you can use that mask in different parts of your program rather than just always writing out the same condition every time. So I'm going to put that back and run this code. Now I am jumping a little bit about in the program, and you'll find that sometimes it's really important for us to not just jump around through the code, and that's particularly when we have to use variables that have already been created earlier, or when we want to make sure that we've imported something earlier on in the program that we're going to use later on. I'm certainly going to make sure that we abide by that during this video talk through. But if you're looking at these sheets yourself, when in doubt, make sure you go through it step by step, one cell after the other cell. Okay, so now notice here we made this mask, and then this mask right here, it shows these two values. So instead of just true and false, it actually just zeroed down into those true values, and so we can see them here. Okay, so if you'll notice, in your workbook, you might have it with a different value here, or a different variable. If you skip back a little bit, you'll notice that I actually called it something different. And the reason I called it that, I don't know why I called it before, but the problem is that made the variable, I wasn't quite clear what it meant. When really, we want to know here, well, how many of the days of the week did we get enough sleep? And so in this case, if we have less than 7 hours sleep, that probably is not enough sleep. And so what we do here is we can get the length of the number of cases in the mask. Then we can get just the length of all of them. And if we divide one by the other, we'll get the average number of those. Now it turns out to be 2 out of the 7 days. So we could just say 2 divided by 7, really. But that's what this represents. So we could print it. If you print it, you'll notice 2 divided by 7. 7's a prime number, so you get a really, really long number, and that's never really going to end. It's just like the way prime numbers work here. So that's not going to look very good, is it? And this is all noise, really, from our point of view. What's really relevant is maybe it's almost 30% of the nights. And thus, down here, you'll notice what I've done, instead of just printing it, I print it inside this thing called an F insertion. And the F insertion says, here's the variable, colon, and then according to this formula. This formula says, give it 2 significant digits because it's a float. So you'll notice now we see a nice number here. And so you can then print out a clearer number, which makes it easier for you to interpret your values, rather than use a whole series of significant digits that where the precision is not really useful. The precision will be useful for the computer, but for displaying it for your interpretation, it might not. It might get in the way, in fact. Now down here, I want to show these multiple masks, and you can see run this to get an error or a longer error. What do we mean by that? Well, the thing is that as I pointed out, we need these parentheses. You put them in there, right there, and that should run fine. But if we don't have the parentheses, it's going to get confused. It's going to say sleep hours less than 7 or sleep hours. It's going to do that first, and then it's going to ask if that is greater than 9. And that doesn't make any sense. So the computer gets confused, as would I. Value area. The truth value of a series is ambiguous. So if you ever get this error, it tends to mean that you we're not sure if it's supposed to be this, or whether it's supposed to be this or this greater than that. So that's a bit of a mess. Now, down here, it's the same thing, but oddly enough, because we use the pipe, it gets really confused. So you see a huge error right there. Can't perform ROR with etc. So what we do here is we put it in the parentheses. Now this will be one series that'll go like, I believe it's like false, 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 true, false, and this one will go false, true, false, 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 whatever. So it merges them together. If either one is a true, it returns a true in the final data set. And then so we see, Tuesday was an aberration of being low, as was Wednesday, and Friday was an aberration of being high. I mean, a good night's sleep Friday night, I suppose. Woke up a lion on Saturday or something, however it's measured. Anyway, that should give an example of how we perform those right there. So you can get data from a series. You can get it as an aggregate or a summary. And here I want to point out the difference between a method and a function. The series has a lot of methods, and methods are properties of the series object. If you look in the code, you can actually see how it's defined as a class series, and then underneath are a whole collection of things that you can do to a series. And so you might say series dot something, and in fact, you can even go over there. Oh, well, let's just hold up on that stuff. You can go over here and let's see. I'll just show this in here for now, but then we'll work back. So sleep hours, if you remember, is a series, right? So we can go dir sleep hours and see that there's actually what a host of possible methods. The ones up here at the top with the underscores, we normally wouldn't use them in our code unless we're doing some very low level things. We normally want to use all of these additional ones here, and you'll see there's resample and quartile and pow and nunique. There's tons of them there. Well, not tons, I suppose. There's several hundred. But indeed, we can see that. And now relative to, let's say, a list, we don't really, that's what we get. So a list, we don't really get a heck of a lot there. And the same for a dictionary too. You don't get many there. So a series, you get a whole lot of extra methods, which are often very useful for managing your data and shaping it in some way or another. Okay, so one of those is value counts, and that's like, I think, a very, very handy method there. So it'll summarize the values. It'll give you, for each unique value in the series, it'll tell you how many times that occurs, how many counts of that particular value. So down here you can see what I've done. Series object 1 1 2 1 1 2 1 2 1 3 blah blah blah. And so it turns out there's 6 number ones, there's 4 number twos, there's 2 number threes. We're seeing one right there and one right there, and there's only 1 number 4. I mean, this kind of descending might start to already feel like a pattern or something, and we might see something like this in a later distribution because it's always like decreasing in order. That's interesting. I'm not sure what it could be. I could make this up. But the point is that the value counts will reveal that for us. We can see that over here as well if we display value counts. We can see that 2 nights there was exactly 8 hours sleep, and 1 night there was 8.5, and whatever. You'll also notice that in this case, It's sorted with the most frequent value at the top, not sorted by index. Now you can resort that, and in resorting that, maybe that's more useful. Maybe we want to go start from the most, how many nights do you get the most sleep or the least? Now, as it happens, because these are fractional values, 0.0 and 0.5, I don't know that they really work very well as an index for me. But at least you can get the idea from a value count statement right here. And as it happens, this value counts is not just output, it's its own series. So you can do things with that series as well. Now down here you'll notice that we have two values here, sleep hours.max and max sleep hours. And they're actually going to give us the same value. So what's the difference between them? Well, sleep hours.max is a method of sleep hours because this is a series, and we go series dot something, and that's a method of it. Whereas a function is its own sort of input-output device, and we put stuff in it, and we get the value out. So we're actually putting sleep hours into the max function. Now, why is that relevant? It's relevant because while you can do this, because there's a method and a function for max, there is no function for mean. Mean is something for calculating among number values, but max, it turns out, is there because it's they just have it for like all the collections. Any collection will have like a max value if you sort it somehow. So while this would give us 9.5 for both, this one won't. The top one will give us the mean, but the bottom one would throw an error. And you'll notice here we've caught that error. Right, so you can add data to a series as well, and we'll kind of show that down here. But the important thing to remember is that it needs both an index and a value. So if you had just this first series right here, A, B, and C, you can't say dot append D. You'd have to give it an index and then assign the value of D to that index. Now, as it happens, right here, there is no third position. We got 0, a 1, and a 2, but we don't have a 3. So in this case, the series will then have a new row, and that row will have the letter D in that position, 0, 1, 2, and 3. If it did already have something in the third position, D would overwrite it. So in that case, you want to make sure that you're managing your indexes or indices properly, as I say here. Okay, so now if you concatenate two series, that's a way to add two of them together. Just be careful if you don't pass reset index equals true, because this one's we'll create a series, and it's going to have the index 0, 1, and 2, and then we'll create a second series, and it's going to have the index 0, 1, and 2. So when we combine them using concatenation, we're going to have the values A, B, C, D, E, F, but we're going to have the indices 0, 1, 2, 0, 1, 2. Now, if we pass reset index equals true, then we'll have the index being 0, 1, 2, 3, 4, 5. Okay, and we can see that over in Jupyter. So you can see you can have a series here, and we have some food, toast, salad, and pastry, and then you look what I've done here. What number did I give it? I didn't put it the number 3. I made it the length of this series. And that's because I know that I'm just using a range index. It's just starting at 0 and incrementing. And so because it increments, I know that the length of the series is going to be 1 more than the last number. So 0, 1, and 2, well, how many elements are in the series? There's 3. So thus, if I use len the series, it's going to add pizza at the end. And see, just look like that. There's 3 and there's pizza. Now you'll notice here we can also check for that. If 2 is not in the series, then create hamburgers there. And you'll notice it's not going to do that. It's not going to reassign hamburgers. But if down here, there is no 4, so it is going to add cookies. So look at that, we got cookies there now. And similarly, you could have just added hamburgers, but I put that if there just to show how we could check on that. Now down here we have some of my friends here, the Muppets, including Kermit the Frog over there. And so we have Kermit, Piggy, and Gonzo, and they're from the original Muppet Show. And the next 3 are from Sesame Street, and the last 3 are from Fraggle Rock. So they'll be Fraggles. So they're all 3 different series. And now if we just want to make one long series with all the names of the characters, we can concatenate them. So you don't just have to concatenate two at a time, you can concatenate multiple series, but it'll add one right after the other. And now look what happens to our index, just like what I mentioned, 0, 1, 2, 0, 1, 2, 0, 1, 2. And so we can see here, ignore index equals true. Actually, it's the ignore index, not reset index. It's a different parameter. So see, ignore index equals true. And also, notably, we added a name afterwards as well. And we're going to display that. Now you can see down here, 0 up to 8, and the name equals Muppets. And so that should be great. Okay, so now you can probably have a look at that and think, what will that series look like? Have a think for yourself. Okay, so you can delete the data from the series. You might have even seen it in the code up there. If you just want to delete one entry, it'll delete series object 2. In this case, it will then now just have these two elements, 0 and 1, and 2 will be gone. So you could go delete series element 0, and actually the new elements are going to replace. Now this is because I did it by position, so you could do that over and over and over again, and it'll just chop the top one off. Or you can make that a label if it's a label, and just kind of get in and get that particular row and delete that. It's not going to reset the labeled index. So if your index was 0, 1, 2, 3, and you delete object 2, then you're going to have, or delete the one in the second position, then you're going to have a 0, a 1, and a 3. It's not going to then change the labels, even if the relative position of the items is going to change. It's worth noting that this right here, interestingly, first, it's one of the few operations in Python that doesn't have parentheses around it, even though I guess it's a function, really, or it should be seen as a function. And the second one is that it's another one where it doesn't send back a copy with the thing deleted. It deletes it from the original. So if you do that, then C is now, it's gone. It's not like we've created a copy without C. Now, if you use mask, you can do that. So you can just use a mask. The new series object says greater than 10. So that'll just have a new series with 55, 15, 20, and 13. It's going to get rid of those two right there. If we rename it to the old series, just like this, then now we've clobbered the old series. That's one way to do the deletion there. So this gets a bit trickier because later on we have to worry about deep copying and shallow copying, especially in a data frame. There's ways that we can return a new data frame even though we think it's the old one, and there's other times when we can rename a data frame and we're actually we think we're operating on two different data frames, but we're really operating on the same underlying data structure, just that it has different names. So we'll have to check on deep and shallow copies in the next video. But for data frames like this, it shouldn't be a problem. Or for a series like this, it shouldn't be a problem. Okay, so we're going to want to be concerned a little bit with missing data. Not a huge amount with missing data, but it does happen and is relevant. So first, it's worth noting that it can be stored as np.nan, that's numpy, numerical Python, and .nan, or pd.na. This is also in uppercase, and these are all in lowercase. Should have been in the monospace font, I guess. But you'll notice here, and I can create a series with both of these kinds of data. Both are missing data right here. And then if I say not NA, it's going to say that's not NA, but that is. And so is that one. So in this case, true, 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 false, true, true. So let's so they both work, and we can do things like just find the elements of the series that are, well, not applicable or not missing data. We can drop them, and we can even replace them with something. Sometimes we might have not applicable data, and we want to replace it with a 0, or we might want to replace it with something else. So we can see that down here in their missing data, working with missing data. We'll see here, I'm going to create a series, and that's the index, and then I'm going to add 2 elements to it. Do you know why I did it that way? Because what's happened is if I've created it with an index, but no data, it's going to have just the indices, and each one of them is going to be missing. And so then I'm going to edit over the first one to have Kermit, and then edit over the third one to have fuzzy. And so here we have, we've added that Kermit and fuzzy. And now that we have this edited like that, well, we can do stuff with the missing values. We can fill them in, see like this. You'll notice that it's not, what this is doing is returning a new series. So we can drop those NA values. And just to recall, if we, if I go, it's still there. So it was returning a new series with the other stuff deleted. And here's another way we can do it. We can mask that. But unless we assign that to a variable, it's just reported that and it's in the air. Okay, and finally, and I don't look at this in the slide, so I just wanted to show this here. You can get the unique values by just going .unique. So Kermit, Fuzzy, Kermit, Piggy, Fuzzy. So there's really just 3 there. And what's interesting is that we made it an array. Now I want to point that out here because an array is a data structure that doesn't have a labeled index. And the reason is because which index would we use? Would we use this one right here or this one? Should it be 0 or should it be 2? Should this index be 1 or should it be 4? Well, it just said no, it's neither. It's an array. It's just unique values from the existing series. So then if we want to turn that back into a series, we can just do this. Just encase it in a series and away we go. So we're nearing the end here now, but some of the last things we're going to want to do are change the order, or sorry, change a series in some way. So first we can change the order, then some values, and then we're going to do that in a more algorithmic way. So you might have seen that above. We can sort the values. So we can sort index, and so here we have a series. We have 3A, 2B, 1C, 4D. Okay, so if we sort by the index, these should go in a different order. It should be 1, 2, 3, and 4, and that's what we have right here. If we sort by values, it actually, just like the one above, A, B, C, D. Now note that this returns a new series unless you put the in-place parameter in there. As a matter of nomenclature, or wording, in place is the parameter. That's the value that we set. And true in this case is the argument. That's how we set the parameter. So we pass the argument true to the in-place parameter in this way. Okay, so we do that and we sort in place, and you'll notice here when we first print it, it'll be 3, 2, 1, 4. But then if we sort the index in place equals true, then we print it again, 1, 2, 3, and 4. And you can also use ascending equals true or ascending equals false with that in order to sort it in either way. And I'm not going to go over to the Jupyter Lab because I think that's pretty self-explanatory there. So we might want to change the type of a series. A series might come in as some strings, and we might want them to be numbers. That's a classic matter, but we might also want it to be maybe a date time or some other feature. So in this case, you'll notice I've put some numbers in here, but I've encased them in quotes, so they would be interpreted as strings in Python. Now, if I use the asType method right here, and I say asType int, it's going to convert them all into integers, and it will do that because it can do that. If it cannot do that, it'll throw an error. It'll get unhappy, and we can set a optional parameter to say errors equal ignore, but then unfortunately it's just going to return the original series, and so it won't ignore per row. It'll ignore the whole series. It'll ignore the whole operation. I don't think that's really that great. But you'll notice here, so for example, we have 3, 4, np_nan, and 2. And if I go asType int, it'll give an error because np.nan is not an integer value. It's a float value. That just happens to be the case in Python. So if we actually convert it to a float, it'll work no problem. It'll be 3.0, 4.0, nan will be in there as it is, and 2.0. So if it can't convert, it throws an error. And you can ignore this with errors equals ignore. Now, one slightly better way to do that, certainly in pandas, is to use the toNumeric uh, method. Now that's a method of pandas, not a method of this series. So actually we insert the series in here, and then we can say coerce as well as ignore. So coerce means take the ones that you can do and the rest of them just leave as is, rather than ignore the whole thing. And so that can give us more options for what we might want to do with our data. And we can see that over here. We're going to change the type. You'll notice like so. And so we have a series of numbers. And if we first convert them to a float and then add 2, this becomes 3.0, 5.0, 6.0, like so. But if we convert it to a string and add the character 2, then it becomes 1, 2, 3, 2, 4, 2, 5, 2, like so forth. Now you'll notice down here, I give an example where we have a series 1 and then the words 3 and then words 5.5. And the computer's not going to get that, even if you might understand that as the number 5.5 and so forth. So if we go as type and errors ignore, then it just gives us back the original set. But if we go down here and go to coerce, see what's happened. It's the ones that it can change. That right there can be coerced to a float, and that one can be coerced as well. But these two cannot, and so they become not a numbers. It's an example of how there's different approaches to changing the type of the variable. Okay, we can change the values as well, and in fact we saw that a minute ago where we added either a string or we added a number, and then you saw 1, 3 versus, adding the number 1 or the number 2. But we can do more with that. Using the map statement, we can take in a value from a series and look for it as a key in a dictionary. And so if it's in there, then it's going to return something back. So we might say 1, 2, 3, 4, 5, French way of pronouncing numbers. And so then what we can do here is say whenever we see a 1, we'll put in that. Whenever we see a 2, we'll put in that. Now, is there a 3 in our series? No, there isn't. It's okay if the dictionary has things in there that's not in our series, because it just, what would be a problem is if it's the other way around. If there was, say, a value here like 7 that's not in the dictionary, then the behavior might be unexpected. I'll let you try that out. I want you to figure out, if we put a 7 in there, is it going to return 7? Is it going to return a missing value? Or is it going to say, there's a value in here that's not in the map? What can I do? Explore that for yourself. But down here, I want to show that this is how the resulting data would work from that map. It takes this one, gets this, takes this one and gets this, and so forth. Now, the thing is that we can also map not just a dictionary onto our values, but a function as well. So in this case, once we have the new series, we have a 3-character word, a 4-character word, a 4-character, and so forth. So just look what I've done here. I've chained them. First, I map on the character, as said for the number in French, and then I chain that series into another map statement where I say, well, okay, so now what's the length of each of these? And you'll notice first I map a dictionary, and then I map a function, and we get it. Well, it's 3 characters. It's length of 4 characters and 4 and 4. Okay, so we can see that mapping again down here. Now, this was actually from the book. This was an example of gender that was imported into data by people. I think it was Prolific or Mechanical Turk or one of these sorts of crowdsourced worker places, and they had a whole bunch of different ways of entering it: man, male sex, woman, female, and so forth. It was very long. It was like several thousand entries, but these were the main ones here. And you can see when I go unique, we have a number of them. And actually, what tripped me up is somebody put in an extra space at the end of female for one of them. But we can see that here. And then what I haven't done is I haven't edited out that space and go, in the original data. I accommodated that using a map statement. And then we say, so for male, make it M. For male sex, M. For female, and the female with the space, and women, make the F there. You'll also notice that I've left out one of the M's here where it says man. There's a couple times there where it says man. So now let's see what happens. Ah, so now we know what it's done. It's created it. It's been not a number. Because it couldn't find man in our dictionary, it just made it not a number. So now just watch what happens when I do this. And now they're all assigned to either M or F. So that's one way we can sort of tinker with that and use a mapping. So that instead of having a whole bunch of different ways of saying what's, I guess, here essentially the same thing, we can simplify that, and then we can use that M or F or whatever measurements we're using in order to more effectively understand our data. You can define your own mapping, and we'll see that. We'll first here down in this one. So the dictionary here says let's make this lowercase. So if we get an A, we'll make a lowercase a. If we get a B, we'll make a lowercase b. Gosh, are we going to have to write out all the letters? What about the letters with accents, their languages, and so forth? It seems like an awful lot of work to do that. So instead, we know that we can use this lower function, and so we can put that lower function inside of a mapping. So in this particular case, we pass in a value. It'll be A, and then B, and then C. And then for each one of those, that's a string object. And so we can take that string object and make it lower, like so forth. And that's great because now we don't have to expand our map. If we go in and we go, J, we don't have to create the dictionary all the way up to J. And if we have like, the letter Y, but it's already in lowercase, it's not going to be a problem. We didn't have to put a lowercase y equals lowercase y. So just having a function then that can do something rather than all of the map combinations can be really effective. And the syntax here is with this lambda, and I use that quite extensively. The thing about lambda is then you can build your own functions inside of it. So here we have one that's a little more complicated. Right here, I'm not just going to make the word lower, I'm going to make the word lower and only take the first character of it. So that's what we call transform word. Now just watch what's happened here. For Alpha, Bravo, and Charlie, it's first taken the first letter and then made that a lowercase. And so that's the transform word function. So now instead of trying to put the whole transform word function inside here, I made it its own function out there, and I can do all the operations there. Now, indeed, we probably could find a way to just go lambda x 0 dot lower. Sure enough. But at some point, we will put a whole bunch of more things inside this function that we just can't put in a single statement. So that's why I'm showing it here. Okay, now I'm going to just get that back to transform word, and there we are. For example, down here we can see how we can make that function a little more involved. For example, passing arguments to it, and so maybe we want to do the whole word, or maybe we just want to do the first character. And so thus now we start being a little more flexible, and what we're not doing is tinkering with this function. We're making use of the function, perhaps a more elegant version of that function that can be more multi-purpose. So we can see that here to review. A lambda function is one that doesn't have a name. It's an ad hoc function. So we say lambda x squared, and I can just say, well, this variable is going to equal that. And so when I say that variable 10, it's going to go, it feeds 10 into here, and then it's going to feed it out through there. So it's 20. Now, you wouldn't use that normally in statements outside of a series, but inside of a series or with a series, it's really, really handy and really useful. So we can see here, same sort of thing. With a series, we would have some values, and then we map x times 2, and that'll double those values, 10, 12, and 20. So lambda works great here since we didn't want to create a dictionary for all possible cases. If you want to do many things for each element of a series, you write that function as we had suggested. And, well, that's the Jupyter code, but we had just gone through it. Okay, so that's it for the series for today. Kind of a lot of different ways that you can make use of it, but just have a review of them, and it's really adding, changing, and deleting from a series. So first we might say that the series is a useful structure in pandas that allows for indexing by both position and label. You can add to it if you provide an index and a value. You give it the next index and some value, and it'll either write over that value if the index is already there, or it'll add that index as a new row. You can use Boolean values to generate a new series or new series, and then use that new series as a mask to filter some of the values out. So we can say, which of the values of the series is greater than 10 or less than that, or has the letter A or whatever. So you can change the values in a series through arithmetic operators, plus, minus, divide, so forth, or through map statements. So be careful for times when you change a series or when you return a new series. Some of the methods we saw here, like delete, change the series itself, and other ones, such as map, returned a new series. So be sure to remember which series you're dealing with as you go through your code. And now the series has a variety of its own statistical routines, but the series is not, honestly, it's not that useful on its own. It's really when we compare different series or compare things under different circumstances. And so for that, we'll need to combine a series into a data frame. That's what we'll see in the next video. So some questions to consider before we move on. Just a little bit, maybe some refresher review, and a way for you to do some of this yourself in addition to any exercises you might find on the course text or in the back of the book. So first, have a think of these. How would you create a series with each letter of a string? Would you include the spaces? And think about the differences below. Is this one, the one string, going to be different than if we create it in a list? Is it going to be different than we say list for one string? What if we went for I in, or for character in string, add to the series? Have a look, and which one do you think will create a series with each letter of a string as its own row? Okay, and now here's a little bit of an exercise for you if you'd like to try this. First, create a really simple meal plan. Like really simple. Just make the index each day of the week and the value your preferred lunch. So first then ask, how would you filter down to the weekdays? And if you have a map of the meals, and then true or false for vegetarian. So maybe you have salad, and then you have sandwich, and then you have pizza, and you know which ones of these are very vegetarian. Maybe all of them, maybe none for you. But then you would say like pizza, true, because well, I always have veggie pizza or whatever. Then you can see not just how do you filter down by the index only to the weekdays, but to the values only by vegetarian or not. So that's just one approach to that, but I'm sure we can find a whole lot more as we get into some real data. And for that, I want to thank you, and I want to get us a little further to that real data in the next video, and that's when we look at the data frame. But that's it for now.